Let's see the concept of complete graph. Complete graph is represented by Kn. So Kn means it is a complete graph with n vertices. Okay. So when you have n vertices, and if you try to put every possible edge, still keeping the graph as a simple graph, then such a graph is called as a complete graph, right? So if you have n vertices, how many maximum edges you can put is, you can choose every two vertices and you can put a edge between them. The number of ways you can choose two vertices out of n is nc2. Therefore the maximum number of edges that you can put in a complete graph is nc2, right? And any simple graph which is containing n vertices and nc2 edges will be called as a complete graph, right? Any ways you can take it. Now let's see the definition of it. A graph capital G in which every pair of distinct vertices is connected by a unique edge is called as complete graph. So what does it mean? Take any two vertices, they should be connected, right? If you have such a graph, then that is called as complete graph. Kn is a complete graph with n vertices. Now take this example, K1. K1 means we have only one vertex. Since we have only one vertex, right? Now we cannot put any edge to it. If I try to put an edge, that will become a loop, which means it is not a simple graph. Now we are talking only about the simple graphs, right? So in a simple graph, this is the only possibility. There are no edges. Now K2 means there are two vertices and I can put only one edge between them, right? And since there is a edge between every possible vertex pair, it is complete. Now what about K3? We have three vertices and I can put only these three edges. Since there is an edge between every two vertices, this is complete. Now again the same thing with this. Since there is an edge between every two vertices, it is complete, right? And again see this. Since there is an edge between every two vertices, it is complete, right? And now every vertex in Kn has degree n minus 1. So if you observe this, the degree of this one is K2, the degree of every vertex is 1. Why? Because every vertex is adjacent to other vertex. Now in K3, the degree of every vertex is 2. Why? Every vertex is adjacent to two other vertices, right? In K4, the degree of every vertex is 3. Why? Every vertex is adjacent to other three vertices. Likewise, in Kn, every vertex will be adjacent to other n minus 1 vertices. That is why the degree of every vertex is n minus 1. Got it? And next one is the number of edges in Kn is nc2. That one anyway you know. Got it? Okay. Now let's see this. A clique in a graph is a set of pairwise adjacent vertices. So you have to find out the vertices and you have to form a set in such a way that all the vertices in the set are pairwise adjacent, right? So which means you should be able to form a complete graph with those vertices, right? So what are the various cliques in this? See this, one clique is 1, 2. Why? Because if you take them, they are adjacent, and other clique is, so like for every, you can take an edge and you can put it in a clique. So how many edges are there? 1, 2, 3, 4, 5. So you can form these 5 cliques simply. So which means, see this, 1, 2, 1, 3, 1, 4, as well as 3, 4, right? And one more is 2, 3. So these are all the cliques with single edges, and also you can find out clique with 3 vertices. So if you observe it, 1, 2 and 3 is a clique with 3 vertices. Why? Because if you take any pair, it is adjacent, which means you can form a complete graph K3 using these 3. And similarly 1, 4, 3 is another clique, right? So you can form a complete graph K3 with this. Now you cannot find out a clique with 4 vertices. If you have to find out a clique with 4 vertices, you have to include all these 4 vertices and you should be able to form a complete graph with that, right? Or 2 and 4 are not adjacent, therefore you cannot find it. In case if 2 and 4 would have been adjacent like this, then you would have formed even a clique of size 4 which will contain K4 there, right? Therefore one other way of seeing the clique is you have to find out the subset of vertices in such a way that you should be able to make a complete graph with that, right? And now there is a concept of max clique. So max clique means what is the maximum subset of vertices with which you can form a biggest complete graph. So in this case the max clique is K3, isn't it, which means you can form the 3 vertices you can take and you form K3s. And the next one is independent set. An independent set in a graph is a set of pairwise non-adjacent vertices. So it is exactly opposite to this. So in this case every pair of vertices should be adjacent, but in this case those pair of vertices should be non-adjacent. Now in this one, if you see this, only pair you get is 2 and 4, 2 and 3, right? So 2 and 3 is the independent set. Why? Because these are the only pair of vertices which are not containing any edge between them, right? So, or if you have something like this, let us say our graph is containing 1, 2, 3, 4. Now let's try to find out independent set. So 1, 3 is an independent set because these two are not adjacent, and similarly 2, 4 is an independent set, right? Now if you observe this, if I try to find a graph like this, and in this graph if I try to find out the independent set, you will not find any independent set, which means in a complete graph there will be no independent set, right? A graph with no independent set is going to be complete. Why? Because we can't find out even a pair of vertices which are non-adjacent, right? Okay, fine. Now let's see this bipartite graphs. A graph capital G whose vertices can be divided into two disjoint sets U and V such that every edge connects a vertex in U to a one in V is called as bipartite graph. Now U and V are independent sets. So what they mean to say is, if we have a graph, if we can partition the entire vertices into two sets in such a way that these two sets are independent, right? If you can get such a partition, you can say that the graph is bipartite. So for example, if you see this, now assume that this is node 1, vertex 2, vertex 3, vertex 4, right? Now these four vertices can be partitioned into two sets in such a way that 1 and 3 are in one set, 2 and 4 are in the other set, right? Now what should be the properties on these two sets? All the vertices should be present in these two sets. That is why it is called as a partition, right? And second thing is, inside each set the vertices whichever are present should not be adjacent to each other, right? Which means it should be independent set. So simply to understand, if you can partition the vertices into two disjoint sets in such a way that these two sets are independent sets, then that is a bipartite graph. Got it? So see, here we got these two vertices in this set which are non-adjacent, right? And these two sets are in this set which are non-adjacent. Now if you want to draw it in other way, you can put it in other way, like this. You can write, generally this is how we represent bipartite graphs, isn't it? So by writing like this, you might not understand that it is a bipartite graph. Yes, it is a cyclic graph, okay, but still we can write it this way, then it will be easy for you to understand. So let us say this is node 1, vertex 1, vertex 3. Since these two are present in one set, I am putting them in one side, and the other one is, let us say 2 and 3, I am putting it in the 2 and 4, right? I am putting it on the other side, right? Now if you observe this, between 1 and 2 there is an edge. Similarly, between 2 and 3 there is an edge, right? And between 3 and 4 there is an edge, and between 1 and 4 there is an edge, right? Now if you see this, between these two there is no edge, and between these two there is no edge, right? And also every vertex present in this set is connected to every other vertex present in this. Similarly, every vertex present in this is connected to every other vertex present in this. That is why it is also called as complete bipartite graph, right? So complete bipartite graph with two vertices on one side and two vertices on other side, K2, 2. You can also call it complete bipartite, right? Now what is the property of complete bipartite? Every vertex here is going to have is going to be adjacent with every vertex on the other side, right? Then how many edges do you have in that? If you have kmn, what is the meaning of it? Let us say kmn. So it means that there is a set of m vertices and there is a set of n vertices in such a way that every vertex here is adjacent to every vertex there, which means every vertex will give us n edges, isn't it? So that it is adjacent to everyone here, right? Therefore n plus n plus n plus n so on m times. So m into n will be the total number of edges in a complete bipartite graph. Got it? Okay. Now look at this example. Even this is a bipartite graph. Okay, so it is nothing but the representation of this graph, isn't it? Okay. Oh no, this is a different one. So let's look at this example. If you see this here clearly, this is one set and this is other set. Now all the vertices here are not adjacent to each other, which means this you can call it as an independent set, and this one is an independent set. But then it is not a complete bipartite. Why? If you observe this one is not adjacent to these two. In a complete bipartite, every vertex has to be adjacent to all the other vertices on the other side, right? And also this one is a bipartite graph. How? See this. Now let us say 1, 2, 3, 4, 5, 6. Now if you take 1, 3, 5, they are not adjacent to each other. Therefore 1, 3, 5 will form an independent set, as well as 2, 4, 6. It forms an independent set. Got it? Now we have two independent sets, and we have edges going crossing over these two sets. Got it? So once you get two independent sets, that is bipartite. Got it? Okay. And one more property is a graph is bipartite if and only if it has no odd cycle. So what is the meaning of it is, okay, we shall prove this. A graph is bipartite if it has no odd cycle, right? So how to prove it is, see this. I am proving the if part, not the other side. Okay. Now assume that, so what is the cycle? Assume that the graph is bipartite, which means you can partition the vertices into two sets like this. Let us say there is a cycle which is starting from this vertex and ending at the same vertex. A cycle is starting here and ending at the same vertex, right? Now I want to say that that cycle can't be a cycle of odd length. The reason is, if it is a bipartite graph, if you have to form a cycle, you have to go to the other side and again come back, and again go to the other side and again come back. Therefore if you want to end at the same node, definitely you should have taken even number of edges. Got it? Why? You have to go to the other side once and again come back. Now let us say you are ending at the same node, starting and ending at the same node by taking odd number of steps. Then what would have happened? You would have taken even number of steps to cross over the sets, and one step would have you would have taken either inside this or inside this, which will prove that this is not a bipartite graph, isn't it? Now we have considered that the graph is bipartite, and under that assumption I have solved this. But then we came to know that if there is an odd cycle, then it is not a bipartite graph. Therefore there cannot be any odd cycle, right? So anyway, proof is not required. If you can remember it, this point is enough. You don't worry about the proof. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.